3, 2, 1. 3, 2, 1. Oh, don't do this to me. It really fails on... Are you kidding me? OBS, man. Don't worry, I got this worked out. Got a piece of hardware coming after Christmas. Doesn't matter. Gonna get this done. 3, 2, 1, go. We're live. This is Retrace segment number 90, Re90, for Thursday, December 22nd, 2022, 10 p.m. Eastern, 7 p.m. Pacific. Retrace is about what's going on out there. What the hell does that mean? Let me tell you what it means, or at least tell you enough to know what you need to do to go find out what it means. The short answer to that, what's going on out there? The short answer is computer control, Re22. The long answer is natural, artificial, and strategic intelligence, Re79 through 81. We need a recap. You don't have to go all the way back to the beginning if you don't want to. Hypotheses 1 to 11 are also going on out there. That's Re17. Humanity, the best part, Re54. Retraces for outsiders. This is not about what's going on out there anymore. This is about what's going on right here. Retraces for outsiders, that's Re5, I think is the best place to start with that. Outsiders are not players, Re52. And computer control is player-oriented, Re54 to 55. So now we're learning to play, Re56. That's boilerplate, but it makes it possible for you. Look, we just need to jump into the code, right? We're going to do a quick segment on the map class. I'll tell you about it in a second. It's not a class about maps. It kind of is a class about maps, but not the way you're thinking. And then we're going to do a doubleheader tonight. We got to go late. There's things to do. We're running out of time. The year's almost over, and the priority queue is not working. So we got to go late tonight. It's all fun and games. All right. We're in the December to Remember Math and Code event. We are preparing for our deep dive into AIMA4e, Artificial Intelligence, a Modern Approach. My book has been sitting lonely, open here for days on the same page because we've been type-a. Love it. Happy. Book's not happy. I'm happy. What does that mean? We're front-loading in December the math, the code, to make sure we have our chops for when we need them to chop. January to June inclusive, 2023. All right, so now what? Let's have a look at this. I can't believe my stupid hotkeys. It's OBS. It's totally. Let me see. Is this going to work? That's so. I don't know what's making it fail. It doesn't matter. It's not your problem, but it kind of is. Okay. I can't fix it. I've tried to fix it. Okay, it doesn't matter. So here we are, back in our source code, and today we're going to be working on. It's really the OBS thing is driving me crazy. All right, we're going to be working through. Just make sure we understand the class map. Okay, we just have to get just to make sure that we understand it. We don't have a lot to do. We understand it, but let's not be so sure. And over here we start at the more or less the top of the file. I've got some stuff folded. There's some imports and blah blah blah. But really, what we care about is we have to define a problem. Actually, you know what? I forgot one thing. You can see this? No. There. Yesterday, I was having trouble finding the type of a thing. It's because this is not a built-in function. Even though it's on the built-in functions page, this is a class. This is not a function. And so I was confused. So that's to do with the type object, not type built-in function, which it is not. And we are... This is AIMA4e's homepage. This is the A to B state space, A Arad to Bucharesti. I think I'm pronouncing it. I'm pronouncing it coolly, if not correctly. Here's our search tree. Our search tree, yes, that we're going to superimpose on the state space. And here's the source code we're going to be working from. So basically, precisely, we need to formalize our the idea of a problem, which we've done. This is Re83, and I think we did it the day before. Maybe Re82 has it too. Does it? Re82 has other stuff. Yeah, we introduced the idea of formalizing a problem in Re82, and that means you need a state space, you need an initial state, you need a goal state, you need actions, you need a transition model or a result function that takes the state and an action and returns a new state. You need an action cost function, and you need to distinguish between that function and evaluation function, objective function, which are different. Okay, that's where we're at, and then there are plenty of other things for you to look at. We'll stay here. So here's the source code that they provide for us on page. What the? I don't even know what page it's on anymore. It's on AIMA page 73, not 40, 73. The hard part of this is really the problem, and as we'll deal with in the second of tonight's segments, the evaluation function, which is going to sort our frontier queue and that's not working yet. But anyway, everything else is working. So we've been working on what this object is, what it looks like in source code. Let's have a look. So here's our class, our parent class of problem. It's a subclass of object. It has lots of placeholders, like the actions available at a given state is not implemented, but it's placeholded. Placeholded is something. And then the result function, which takes a state and an action and tells you what state you'll end up, if any, what new state, if any, also not implemented. Is-goal is easy. You provide the goal as part of your argument. Up here, they don't give an example. I thought they did. Doesn't matter. It's part of the argument to the problem when you instantiate the problem. Action cost, that's going to be our mileage when we get to that. And then heuristics we're not dealing with informed search right now, so we're not dealing with heuristics. And then just here's some mechanical stuff, the string, and then the init is the, up here. Yeah, up here. Here's the initial state, the goal state, and the keyword arguments. We're actually going to use a keyword argument, keyword map, but we're not going to instantiate a problem. We're going to instantiate a subclass of problem, route problem, okay? Because we're trying to solve a route problem. So here we have a more implemented actions method. No longer says not implemented, obviously. Same thing with results, our results method. And then our action cost is more apropos to our route class of problem. Okay, so that's what gets us down to class map. Okay, what is class map? Well, this is going to be part of our problem. It's going to be a crucial part of it. It's going to the map is going to look like this. Let's see. Oh, I got a new way of doing this. There we go. That's nice. Okay, so let's say we want to instantiate a map of Romania corresponding to, this has got to be better. This is no good. I don't want to have to do this. No. Yes? No. The map, it's easy to draw a graph of a map, but this is not going to help the computer very much, not in its current form. It's not even really a Cartesian illustration because it doesn't have the coordinates. We have those here, okay? So down here are the locations. These are the states. This is the state space, or the states part of the state space. And for it to be a state space, I think for it to officially be a state space, it has to include the actions, which are here, and these also include the costs. But I don't think we need the costs here, but we need them later. So, but you could have actions in a state space without the costs, like getting, you can go from O to Z, okay? That's an action. You don't need the cost unless you're doing real work and living in the real world, which we probably will be when the time comes. Okay, so our map is going to look like that. It's going to take those two arguments. What's going to happen to those arguments? Well, the first one is going to be links, or is going to be called links. The second one is the states, which we call locations. And then is it a directed, what would you call it? State space, or are we doing a directed? Does our problem have direction? Can we go backward and forward, or only forward? In our case, we're only dealing with an undirected or non-directed circumstance. I don't know the lingo that I should be using here. So first of all, this map class checks for the attribute items, and if it doesn't, now that's our Romania. That's our costs here, which are miles. Okay, 71. O to Z is 71. Please just go right. There we go. O to Z. Where's O? Show me an O. Show me a Z. Show me either one. Where are O and Z? O or a dea to Z's are in 71. Okay, that 71 is that 71. Okay, so if our what's the best way to do this? Probably that. If our links object, which is our actions dictionary down there, has items, and we've figured out previously in the last one or the segment before that items corresponds to those costs or those miles. then if it doesn't have those items, then we want to populate it with just some default values. Okay, default 1 in our dictionary for link and links. Okay, so we're going to just, instead of, if we didn't have the 71, we just populate it with a 1. Here we're checking for directedness, and if it's not directed, then we want to add the mirror image of the list of links, which is actions. So basically you want to be able to go, to represent it to the computer, if this isn't a directed, gosh, I got to figure out what the noun is that I should be using. I want to say directed state space or directed search algorithm. If it's not directed, that means we can go to rod and go back to Zarind. Okay, so we only have entries in our dictionary, if it's, gosh, I guess we could, what if our links dictionary already had the reversals? Well, anyway, this would cause duplication. Actually, it's a dictionary, and if you've got two entries, will a dictionary accept 2 entries? Where's Alexander? Where's, if we have 2 entries that are identical, will it repeat those entries? I don't know. I'm not a programmer. Okay. Anyway, if we give it the entries we're giving it, which are in just one direction, the non-directed little, this is a suite. Okay, this is a compound statement with that colon and then a couple of lines. It's actually 2 compound statements. So this is the suite, and this is a header, and then this is another header. And so what it's going to do is modify our dictionary so that it has the reverse directions in addition to the forward directions. That's all that does. So what that looks like is, if we've got O to Z 71, we need to add an entry here that's Z to O 71. Okay, class map. Nope. Oh, not two. Jeez. How do you spell map again? I struggle sometimes. Oh my goodness. I'm going to go crazy. This is this is Emacs hell. I'm going to stick with it. Command S or Control S. Previous. Get the second P out of there. Do that. Do it again, and hit return. Okay. See, Emacs is so easy. I don't know why people. Of course I do. Okay. I'm going to start playing with Vim too, because this is ridiculous. Like, there's some things that I want to see if Vim is better. I mean, I know some Vim, but I'm not like Emacs-y in Vim. Okay. Self.distances is just the links. This just returns, let's have a look here. So we're going to, first, okay. Let's source in. Can we source in the file yet? I'm going to demonstrate these things, okay? So there's nothing to demonstrate here. Our links dictionary is going to have items in it. So instantiating a map is not going to change our dictionary, the dictionary argument that we send to it, the links dictionary. However, as we've seen previously, this is going to happen. It's not directed, and we are going to see our links dictionary get changed. But I gotta, okay, so how do I do this? No comment. There we go. Okay, so we have tmap is already instantiated here, so I gotta comment that out so it doesn't happen. Oh, no, it disappears. And then we don't need problem right now, but we need those other things. Okay, no comment. All right, now we're going to source this into IPython. Load. Yes. Good. Now we've loaded all of our source code into IPython's memory, so we can play around. What the heck is our map called? I think we didn't even instantiate it, did we? Oh yeah, we're not going to. Okay, so first let's just print tlinks. No, because tlinks looks better if you don't print it. Yes, look at that. See how it's all new liney? I love that. If I do, darn it, I gotta do this the stupid way. Okay, then it's like one line. That's not as cool. I don't like that. Okay, so tlinks looks like that. Let's instantiate a map. Map equal tmap. Oh yeah, there we go. Tmap equals an instantiation of the map object with the argument tlinks, which is our actions or our links dictionary, and T locations, which these are just our toy and toy. You know, I said it's meant to be test, but it really should be toy. This is the toy version of the problem. So T links, we're giving the argument of T links to the instantiation of map, and then we're giving the argument of T locations. If you don't do the T locations, I think it throws an error. I did this today, and I just don't remember what happened. Okay, so come on, watch this. This is going to get easier. It's going to get easier. Okay, so let's do this. Let's instantiate a map. Remember what T-links looks like. I'm going to be able to show you, but just also remember it. I don't know why. Just do it. All right. Look at that. Look at that. Okay, so now we've got T-links before the instantiation of map is 6 entries, and after it's, 12. Okay, oof, I thought for a second there was too many. And what you can see here, oops, no. Oh, you're so terrible, IPython. You're so, oh, and it doesn't show, what the heck? That's so not cool. That's so not cool. Can I get it back? Why? That's never happened with it doesn't matter. Okay, watch this badass I'm gonna do right now. Yes. No, yes, T-links. No, I can't, there's no T-links. Load. Okay, yes. That's the only thing I don't like about IPython is this, like, showing me the whole darn thing. T-links. Is that, okay, and then we instantiate a map, tmap, and then we look at T-links again, and bang. Okay, so now we've done that directed modification, and because it got passed out of the class map, the class map, it got passed to our function multimap, and multimap has side effects because it's not, it's a standalone function. It's not a method within, what am I talking about here? I've got multimap totally hidden, but anyway, right here, multimap gets past links and it modifies it. Okay, so we've got our reversed T-links, and that's as expected, as we've discovered. So that's what just happened here. Okay, T-links got modified and doubled in size and has the reversible actions now, and then got passed out, and so it's modified in IPython's memory, so we can, you know, it's not just it's not an isolated situation. That seems, I've said this before, it seems like it shouldn't be that way, but I'm not a programmer, so I don't know if that makes sense to other people. Let's have a look now at our tmap. Shall we look at distances? Look at that. Distances returns just the modified T-links dictionary. So previously, our dictionary, the dictionary argument we gave only had these links in it. Actually, not those. That's not the test one. Where are we going here? Here. Had these entries, 6 of them, I guess it is, and now it returns the modified one as the distances, because that's what they are. That's all that data is. Okay. Let's do neighbors. These are our actions that we work so hard to get. This one's beautiful to me. A's neighbors are ZST. Yo's neighbors are Mama and T. By the way, I connected the Yo Mama world to the AZST world because I wanted them to, because I want my problem to be able to search through the Yo Mama world. So that's why that second entry, it has a T in it now. Didn't before, but we changed that. And what that just looks like is Mama. There we go. It's just this last entry here. Look, I added, to get from T to Yo, 38. And what that looks like in our new modified dictionary is to get from T to Yo, 38, but also from Yo to T, 38, right? It's all fun and games. All right. And then, so our neighbors are, our neighbors attribute, as achieved by the multimap standalone function, is all of our actions available at a given state. So if we need to know what actions are available at a given state, this dictionary is a lookup table, is a lookup tool for us, or lookup, an object that we can use to look up the answer to that question. Okay, locations. Did we already do locations? No. Tmap. Locations is just going to be the states. Okay, in our little, it's not the T-links, it's T-locations. There's nothing complicated about it. In our toy problem, it's that. In our Romania map, it's going to be these things. Okay, these are just the states, in the state space, but it's not a state space until we have actions. Please hope that I'm saying that correctly. Okay? Oh, geez, I'm getting better and worse at the same time somehow. All right, let's do this so we can see the whole thing. That's it. Oh, and the locations. Okay, so the lambda function is, this is like sort of an anonymous standalone function. Like there's no name calling it from outside, but this doesn't do anything. This has just got to, I think this is another situation, as we learned from our friend Alexander, where you need to give some sort of argument, or you're going to raise exceptions or throw errors with some of these fancy containers. But I don't think that's important. I fiddled around with it. It doesn't do anything important. And in any case, in our particular problem, which we're keeping our horse blinders on, we have locations. Okay, we have locations as defined by our argument to the problem, which is just let's t locations. It's this. Okay, so if we didn't have these, the lambda. Now this is bothering me. Okay, if we don't have locations, it doesn't throw an error, does it? That lambda thing does something. Does it? Let's have a look. To reset. Yes. Okay. All I have to do is instantiate the tmap equals, but let's take out the locations. Map is not defined because I nuked the thing. Load. There. Now is it defined? Oh, don't do that to me. Oh, I gotta do this. I gotta figure this thing out. I'm not good in IPython. Now is it defined? Yes, it is. No errors. Okay, that's interesting. Let's investigate a tmap with no locations. First, let's. We should have printed. It doesn't matter. Let's print tmap.tlinks. Not .tlinks, neighbors. Okay. It has 7. Oh, I haven't done this before, so I don't know what I'm dealing with here. 1, 2, 3, 4, 5, 6. That's weird. Oh yeah, it's just the neighbors. Of course it doesn't. I was thinking it was supposed to be the double. No, that looks normal. Okay, so neighbors is normal. But this is not going to be normal locations. Yeah, see, there's the. So I guess. Oh, here's another experiment. Okay, let's do one more experiment, and then we'll be done. I swear, we'll be done with the maps, the map class. I want to get rid of this lambda thing, and hopefully break it in a way that makes sense. Okay, so no more lambda. Actually, that's bad form. And now we comment that out, and now we're that. Okay, do we reset? We reset. Load. Yes. Do I want to do anything before I do this? No. Tmap equals. And yes, so now I'm going to, let me just think about this for a second. I'm going to instantiate tmap without locations. Yes. So in order to test that I didn't modify the damn file. I'm just doing the same thing I did. Pardon me, everyone. Pardon me. I'm just too fast to be also good. We want to be both, don't we? Okay. There. Now, let's try this one more time. Load. Yes. And tmap equals map.links. Now, we're testing what happens if we give no locations. Okay, so we know it's not going to be this, so it's going to switch to the or default dict. What's going to happen? I don't know. I've never done this experiment. Nothing. Okay, so tmap.locations. So it's just that. Okay, so what does it look like? Oh, damn it, I just cleared the damn screen. I hate this. Why? This is the only thing. Oh, no, now it's working. Why? Oh, I should have just gone up higher. I think it's because I cleared a screen. Okay, it doesn't matter. Okay, so we did a tmap with the default, with the lambda function in there. It looked like this. I gotta capture this because this is gonna drive me crazy. I just don't want to have to repeat this. Gosh, did I already do it? No, I didn't do it. I didn't quite do the experiment I'm doing right now. Okay, so that, and that's with the lambda. With lambda. And now, let's go back and look up without the lambda is easier. Is this. Okay. And let's compare. Without lambda. So with the lambda in there, you get function main map.init locals lambda. Nope, I have no idea. It's doing something, but I can't explain it to you, and it's not important enough to dwell on because we have other things to do. Okay, so that's it. That is the map class, and we are going to now move on to the priority queue because when we go to actually, we've basically built a problem, a real problem. We have a route problem is the class, so we instantiate route problem. We give it initial state, goal state, and then the map as its arguments. And the first problem with route problem that emerges that we need to deal with next is oops. What is it? Search route problem. Did I really hide it? Problem. Okay. Oh, I commented it out. No, I didn't. That's ridiculous. There it is. Okay. What it does, we give it the problem. It's not the route problem. The instantiating the problem is not an issue. We haven't. It's when we go to use the heuristic, the best first search. The whole point of this journey, and that's I think in here somewhere. Where the hell is best first search? I don't know. Best. There it is. Okay. I gotta get rid of a lot of folding here. It's right here. So when we give our T problem to best first search, and I just gave it like an integer here as our evaluation function, but that's going to be a problem. It sets a node equal to the initial state, and then it tries to define the frontier, and what we run into is this priority queue. Okay, this. Oh man. This here was not defined when I did it, and then where is it now? Here, yeah, it's right there. Here's the guts of priority queue that we need to get into, and the real issue is like down here. It's this thing here. Me passing it a 10 for that F causes an issue at that line. So we'll get into that, and that's where we're going next. And we're doing a double header. I am really bothered by those hotkeys, but don't worry, I got a solution. I hope it's a solution. I think it's a solution. All references and all code will be in the PDF notes as usual. Check the RSS feed, check the YouTube description section. This has been segment number 90. We're doing 91 as soon as I spin it up, probably half an hour, which is putting us at 11 p.m. Eastern, maybe a little bit later, but I'll tweet it. Signing off for now.